Now we are going to start with a new chapter called as continuity and differentiability. In this video, we are going to see a quick recap and review of what was limits, what we studied in class 11th. Now we know that continuity and differentiability is altogether a very different and new chapter for us, but we have already studied limits, and study of limits is very much essential to study continuity, and study of continuity in turn is very much essential to study differentiability. So these all come under the category of calculus, as we all know, and it is very important that you please revise all the concepts of limits of your previous class before watching this video. I will be taking a quick recap of limits. Now whenever we used to see limit fx wherein x tends to a is equal to L, what did we mean by that? LIM, when you see, means limits, that we are talking about limit. Now x arrow a, this arrow is read as what? This arrow is read as tends to, remember, and a is given to me. Fx is what? Fx is the function that we are taking into consideration, and L is the value of that function. It means what? X tends to a means what? X tends to a always means that my x is neither equal to a, that means it is not equal to a, but it is very near to a. Not equal to a, and what else does it mean? It also means another important thing, and that thing is that the function value that given to me is equal to L, it is not actually equal to L. Fx is expected to be equal to L, but it is actually not equal to L. That we need to know, and that we already know from our 11th class. That means what? We are basically talking about A, wherein we are talking about the neighborhood of A. That means I have A somewhere here. Now I can reach A from the left hand side, from this side, as well as from the right hand side. Talking about the left hand side and talking about limit there, we say it is LHL, which is said as left hand limit, and talking about the right hand side, we say that it is RHL. All these things have already been studied, and we also saw that limit always exists in case that left hand limit is equal to right hand limit, and that should be a finite number or quantity, right? Suppose we have this example. Now this example talks about fx. Fx is what? It is equal to x square minus 9 upon x minus 3. Now what is the value of function when my x is equal to 3? Suppose I talk about x being equal to 3. What happens? Fx is equal to 3 square minus 9. My solution changes to 3 square minus 9, which is 9 minus 9, which is 0, upon 3 minus 3, which is 0. That means I have got an indeterminate form. This form does not exist in reality for us, for our study of mathematics. So this should not be the case. Since this should not be the case, what we do is we apply the concept of limits in these questions. We have already done these type of questions a lot in our junior class of class 11th. What we do is we basically take fx, and here we take limit x tends to 3. You have always seen that for limit either you can use LIM or you can use LT. What happens then? It is limit x tends to 3, and the question is x square minus 9 upon x minus 3. For solution of this question, what you do is you basically factorize the numerator. It becomes limit x tends to 3, x square minus 9 can be split in the form of x plus 3 and x minus 3. Why? Because it is basically the formula of a square minus b square, which is a plus b into a minus b. So it is x plus 3, x minus 3 upon x minus 3 upon x minus 3. Some things get cancelled, and ultimately what we get is we basically get limit x tends to 3, x plus 3, put the value of 3, you get 6. Now some students think that okay, if you get 6 it's very good, it's fine, but exactly what I mean to say, and actually what I mean to say, is that fx is expected, fx is supposed and thought to be and assumed to be reaching 6 when x is expected to approach 3. So that is why it's known as the concept of limit, that the limiting value or the neighborhood actually is into consideration. If you have somewhere 3 here and you see that you can approach 3 from left hand side and right hand side, this becomes your right hand limit, this becomes your left hand limit, and just near to that, just near to 3, suppose I see a point that may be 3.00001, and just near on the left hand side it may be 2.9999 and so on. So that means when these values are also there, the function value is expected to reach 6 and not exactly equal to 6. So with this introduction and with all the previous concepts on limits of class 11th, which you will watch and study yourself, we will start in the next video with the actual topic, that is continuity.